So in this video, we're going to be looking at rationalizing our denominators. So the learning objective I've written here is to be able to rationalize your denominators using conjugate surds. So hopefully by the end of this two-part video on rationalizing denominators, you'll be able to rationalize a surd, explain what a conjugate surd is, and that you can rationalize a denominator that contains a sum or difference of surds. So you might be wondering what exactly rationalizing a surd looks like. So basically here, we know from experience, it's always easy to simplify our fractions when they have the same denominator. So by this principle, it's actually the same when we're working with surds, especially when they start to look a little bit more complex, like the second example where I've written root 41 divided by 2 root 11. And again, it's easy to work with them as well when the denominator is expressed as a whole number. So because of this, we rationalize the denominator, which means that the denominator is converted from an irrational number to a rational one. So if we take a look at the general example I've written here, I've written y divided by root x is the equivalent to writing y divided by root x times root x divided by root x. So you can see here that we have basically multiplied the original expression, so y equals root x, by the denominator on both the numerator and the denominator. So the reason being is we don't want to change the question, because if we multiplied it by anything else, and when I say we multiplied it, I'm talking about the original statement. If we multiplied that by anything other than root x divided by root x, we're actually changing the question. Remember that root x divided by root x is going to equal 1. So really what we're saying here is that it's y divided by root x multiplied by 1. The only difference is 1 is actually being rewritten as root x divided by root x. So we're sort of unsimplifying it, if you will. So if we look at some of the worked examples here, now I haven't written an instruction, which was my bad, but basically what I want you to do is to rationalize each of the following surds. So let's have a look at them and see how we do it. So hopefully each of these questions are a little bit more difficult than the last, but the same principle still applies for all of them. So let's rationalize the first surd. So we've got 3 root 2 divided by root 5. Now to rationalize the denominator, I'm going to multiply that by root 5 on root 5 because root 5 is our denominator. So now simplifying this, I'm going to get 3 root 10 divided by 5. And the reason being is, remember that root 5 times by root 5 can be written as either root 25, which equals 5, or you can choose to go root 5 squared, which is the same as saying 5 to the power of a half, and then that's to the power of 2, multiplying out our powers. We're left with 5. So either strategy you use is fine, both will get you to the same answer. So you can see here that our final answer is 3 root 10 divided by 5. So what we've done here is rationalized the first question and made it so that the denominator has gone from being an irrational number to a rational number. So following this principle, let's try the second question. If you want, I would highly encourage you to pause the video now and give it a go yourself, and then and then play the video and see whether or not you got it correct. If not, feel free to continue watching. So here I'm going to rationalize this surd as well. So that's 5 root 2, and I'm going to rationalize it by writing 5 root 2 divided by 5 root 2. So here what I'm going to do is actually simplify my numerator and simplify my denominator. So doing my numerator first, I get 10 root 12 on 25 root 4. So simplifying my numerator again, I'm going to have 10 times root 4 times root 3. And then that'll be 25 times 2. So now simplifying this, I've got 10 times 2 root 3 on 50. So simplifying this further, I've got 20 root 3 on 50, which will simplify to 2 root 3 all on 5. And then the last one is going to be a little bit trickier, but it's not going to be too difficult. So let's rationalize this by multiplying it by its denominator. So here what we're going to do is basically, it's going to end up looking something like this. And I'm just going to simplify my denominator to 5 because we know that it's going to be that. So then I'm going to have root 5 minus square root of 25, because essentially what I'm doing is I'm expanding the bracket, right? So I'm multiplying all the terms in the bracket by the root 5, and then divide that by 5. So I'm left with root 5 minus 5 divided by 5. Now if you're going to simplify it here, be very careful. If you are going to simplify it, then I would write it as root 5 divided by 5 minus 5 divided by 5. So that'll leave me with root 5 divided by 5 minus 1. So be very careful when you're doing that, because what people can tend to do is just think, oh, there's a common denominator of 5 or a common number of 5 or something, and basically rewrite the whole thing as that. Or there could be many other mistakes people make. So just make sure if you are looking to simplify it further, it might not be a bad idea to sort of split up all the terms and make them their own individual fractions. So hopefully now you feel a little bit more comfortable rationalizing surds. In the next part of the video, I will be looking at rationalizing conjugate surds. So they're a little bit more complex, but the theory still remains the same, but you do need the foundational theory of rationalizing a denominator.